All right. In geometry, when we measured angles, we always measured in degrees. There is another way to measure, and it is more common to use in things like equations and whatnot. So we're going to talk about them now. Radians is just another way to measure. And gives you a little history here that in the late 1800s, you got mathematicians that needed another unit of measure. So 1 complete circular revolution is 2 pi radians. So if you recall, a circumference, or the perimeter, remember it's called circumference, is actually 2 pi times the radius. That's where it comes from. So therefore, 1 radian is approximately 57.296 degrees. We're going to do something called the unit circle later, and it's going to be very important that we know those things. So our central angle, hey, I was ahead of myself. If we look here, it's talking about the circumference is 2 pi r. Okay, so if the radius was 1, then you would have 2 pi times 1, which is just 2 pi radians. So that's just kind of where it comes from all the way around and so forth, okay? You are welcome to research more in depth exactly what is a radian, but as far as what I want you guys to know is converting between the two. So we'll come back to these common ones in just a second. Let's make sure that we know how to convert between the two. So if you're going from degrees to radians, you're going to multiply by pi over 180. If you're going to go from radians to degrees, you're going to multiply by 180 over pi. So just the reciprocals of one another. And so you just have to remember your fraction rules. So notice the left-hand column in example 4 is all radians. So to get to degrees, I'm going to multiply by 180 over pi. So we're going to try to get degrees. That means we want the pi's to cancel out. So then I have 7 times 180 over 6. So it is up to you how you do this. If you put 7 times 180 in your calculator, then divide by 6. If you reduce 180 over 6 and then times by 7, whatever it takes, your answer should be 210 degrees. Remember, negative just means we're going in a counterclockwise direction, but our rules are the same. We're going to multiply by 180 over pi, which means our pi's cancel. So that means I have 2 times 180 over 3, and it is a negative times a positive, so my answer is going to be negative. So I get negative 120 degrees. And one last time, if I multiply by 180 over pi, the pi's cancel. And so for this one, I get negative 96 degrees. Okay, what if I want to go the other way? So I have degrees and I want radians. I'm going to multiply by pi over 180. So if I think about 135 being over 1, I need to multiply straight across, because that's your rule for fractions. And then I just need to reduce that fraction. If you are terrible at reducing, no worries. I'm not taking Desmos away from you. So all you have to do in Desmos is 135 divided by 180. Notice I do not put pi in there, okay? Do not put pi. And then over here on the left-hand side that's blue, the little fraction, if I click that button, it will change it to 3/4 for me. So I know that 135 over 180 reduced is 3/4. So that means that this is actually 3 pi over 4. So I just carried the pi over and reduced 135 over 180. And I do that every time. So negative 320 pi over 180. 320 over 180 reduces to 16/9. So I get negative 16 pi over 9. And one last time. Reducing 110 over 180 gives me 11/18. It's negative. Pi has to hang out with it. So one last part here. Let's go back. Our most common pi over 4 is 45 degrees. So the sooner you memorize this, the easier your life will be. Pi over 2 is 90 degrees. And pi is 180 degrees. So what does that look like? If I start here, that's when we're on an XY coordinate, that's where we always start. 180 degrees is just a straight line. If I start on the positive x-axis, 90 degrees is straight up. And negative 45 degrees, so that means I start at the x-axis and go in a negative direction 45 degrees. I would be right here. It is also typical to put your arrow in the direction that you're going to state which way you are going. All right, so next activity, try converting back and forth. Hopefully you get quicker. That is the idea. It may be easier if you open Desmos on your phone, so you're not having to go from tab to tab, but give it a